Hi dear students, welcome back to mathematics online class. In a previous video, we have studied that what is the line in a space, what is the direction cosines of the line, what is the direction ratios of the line, then equation of the line in a different forms, equation of the line whenever one point on the line and parallel to the other vector is given. And next one, equation of the line whenever it passes through the 2 points. Then distance between the two skew lines, distance between the two parallel lines, and angle between the two lines. These are all the things we have studied about the line. So in a space, how to determine particularly a line? Line is going to determine particularly it passes through the single point and parallel to the vector B. Then we can get the particular line. You can easily determine the required line, or else it must be passes through the 2 points. On these two conditions, a particular line will get in the space. Now, this is all regarding the lines. Now, the next point is the plane. Instead of considering the line, we are going to consider the plane. Here, I am just suppose it is a plane is there. Suppose I just take, suppose it is a plane is there. Now I need to define or determine this plane. This plane is exactly present in the space. So here, how to determine this plane? So to determine the plane, in the space, there are particularly the three conditions are there. What are the three conditions are there? Means the plane should be, suppose it is a plane is that in a three-dimensional or in the space. So already know that x-axis, y-axis and the z-axis. Instead of considering that one, I just consider in this case as a planes. So this ground, what is this ground? What are the axes are common? This is the y-axis and that is the x-axis. This is the xy plane. And this board, what are the planes? This is the y-axis and the z-axis. This is said to be the yz plane. And your left side wall is the xz plane. So I just consider the plane. So considering the plane, three planes are mutually perpendicular to each other. Then suppose this is a plane is that this plane is in the space. How to determine particularly this plane? To determine this plane, there are three conditions are there. What are the three conditions? Means a normal is drawn from the origin. Normal is drawn from the origin to the plane. Normal is nothing but perpendicular. Suppose this is a plane. For this plane, I just drawn a normal from the origin. Or suppose this is a plane is that I just drawn a normal from the origin. Where is the origin? Origin is the left side corner. Is that clear? So this choppice is the normal drawn from where? Drawn from the origin. This choppice is perpendicular. Check this. This is a perpendicular is there. Okay. So to the plane a normal is drawn and this is perpendicular to normal is obviously nothing but obviously it is a perpendicular and this distance is given. How to determine the plane in the space? That is, to determine the plane in the space is nothing but a normal is perpendicular to the plane. Normal is perpendicular to the plane and its distance is given. And its distance is given. So plane is that for this plane a normal is drawn from the origin and this normal distance is given. So this form is said to that normal form. This is said to be the normal form. I got my point. How to determine the plane in the space means suppose one plane is there in a space. For this plane, I just drawn one normal from where? From the origin, and that normal distance is also given. Normal perpendicular line is drawn plane to the origin. That perpendicular should be there for the plane. Okay, and that perpendicular distance is always given. So that this form is said to that normal. Normal form is nothing but perpendicular from the plane to the origin and its distance is given. This is the one form. Next, second form. What is the second form? Is nothing but perpendicular distance, perpendicular distance, and one point is given. Perpendicular distance and the one point is given. So one point on the plane. Suppose the plane is for this plane one point is given, and in which direction the normal is that, or in which direction the line is that. That is the given perpendicular distance or perpendicular direction, and one point is given. One point and the direction of the plane is given. That is the second case. Point and the direction. Point and the direction of the plane is given. Then we can easily determine the unit plane of plane. Next, third case is non-collinear 3 points. To determine the plane in the space, there are given 3 non-collinear points. What is the non-collinear points? Non-collinear. Collinear means all the points, whatever the number of points are there, lie on the same plane. Non-collinear means the points are not on the same plane. So 3 points are 3 non-collinear points should be given. 3 non-collinear points should be given. In that case, only we can easily determine the plane, unique plane. Is that clear? Suppose one plane is there. To determine this plane, first condition is a perpendicular distance from the origin is given. Distance is also given. Second case, this is one way to determine the plane. Second one is one point of the plane and the direction of the plane should be given. This is the second case. Third case is nothing but 3 points on the plane. These are non-collinear points should be given. Out of the 3 cases only, we can easily determine the plane. Okay, mention these 3 points. Now, I just directly go to the first one. That is, now we are required to find the equation of the plane. We are required to find the equation of the plane. Equation of the plane in the normal form. In the normal form. Already know that what is meant by normal form. What is the normal form? For the plane, from the origin to the plane, a normal is drawn and this distance is given. Okay, so I just consider the 3-dimensional planes. 3 planes are mutually intersect. This is x, y, and the z axis is there. Suppose one plane is there. However, I just consider the one plane. Suppose the plane is in this manner. Suppose the plane is there. This is one plane. I just taken, this is the plane. This plane is x axis also intersecting, y also intersecting, and z axis also intersecting. Have you got my point? So it is intersecting the extended. This is intersecting the x axis, y axis, and as well as the z axis. In that manner, a plane is there. Are you clear? Have you got the imagination? Now, I am just going to draw the normal. So here it is a plane is there. I am just drawing the normal. This is a normal. From where? From the origin to the plane. So origin to the plane, one normal is drawn. I just call it as a ON. This ON is perpendicular to the plane. Are you sure? Are you sure? Okay. This is the x axis. This is x axis. This is y axis, and this is the z axis is there. In this manner, x, y, z are there. Now I am just consider the plane. How the plane is there? In this manner, the plane is there. Are you clear? The plane is there in this manner. Now I just draw the normal from the origin. From the origin, I just slightly change it. So this is how x axis, y axis, z axis is there. 3D. This is a plane in the space. I need to draw the normal. How? From the origin to the plane. From the origin to the plane, I just draw the normal. Okay. Origin to the plane, I just draw the normal. And normal form is nothing but that distance is already given. So what is the given thing? Origin to the plane, normal is there, and its distance is given. Using this thing, I need to find the equation of the plane. How to find the equation of the plane? First of all, I just write the given thing. What is the given thing? Given ON is the, I just take the vector ON is the normal to the plane. ON is the normal to the plane, and its distance is given as d, and its distance is given as d. Now I need to find left. So ON is given. So next ON vector, I just write the vector. What is the vector I can write? ON vector is equal to d. Is it okay? Left hand side I am just telling that vector. Right hand side I just written a scalar quantity. D is a scalar quantity because the distance is that. For example, distance 2 units, 3 units. It is not suitable. So that means I need to mention the direction. To mention the direction, what I have to write? Can I write it as a unit vector? Can I write it as unit vector n cube? So that ON vector is equal to d into n cube. D is nothing but the length, distance. In which direction? Unit vector n cube. This is the direction. N cube is denotes the direction of the ON vector or direction of the distance. Answer the equation number 1. People got it? ON is this vector. In which direction? N cube direction. How much distance is the unit of distance? Next, let P be the point. Let P be any point. P be the any point on the plane. P be the any point on the plane. Suppose this is the point P with the any point. Then I just draw the P and is. This is the n. This direction. Now the Pn is perpendicular to Pn is perpendicular to what? Pn is perpendicular to the ON. Pn is perpendicular to the ON because both are on the same plane. So this is the normal from the origin. Suppose this is the edge. I just consider for your reference. This is the point P and N. So draw the perpendicular. However, you just take the point on the plane, draw the lines. It is obviously perpendicular. Are you clear? So this is Pn is perpendicular to the ON. Pn is perpendicular to ON. Next, I just take that. OP I just join. OP is nothing but this one. Let R be the vector. Let R be the position vector. We can mention. Let R be the position vector. Let R be the position vector. That we can say that OP. Let R be the position vector of the point. Let R be the position vector of the point P. Now I just take this is in this direction. Now we need the NP. So what we can write the NP value? NP vector is equal to how much? NP vector can I write as OP vector minus of ON vector. Can I write that? NP vector is equal to OP vector minus ON vector. Are you people clear? NP vector is equal to OP minus ON. What is the OP vector? OP vector is nothing but R minus. What is the ON vector? ON vector is nothing but already I just mentioned here. B into n cube. Are you sure? ON is equal to B into n cube. This is the NP vector which is called as a equation number. And apart from that, here from this diagram, already we know that ON vector and NP vector. ON vector and NP vector. This is also vector. This is also vector. If I take the dot product of these two vectors, what is the dot product of these two vectors? Is equal to 0. Why the dot product of ON and NP is 0? Because these are mutually perpendicular to each other. Are you sure? Dot product of two vectors A and B are two vectors. Dot product of two vectors is equal to 0 means the A vector and B vector are mutually perpendicular to each other. So that you already know that OA is only drawn PNP is perpendicular to ON. So dot product of ON NP is equal to how much? Is equal to 0. Are you sure? Call this as equation number 3. Are you people clear? ON dot NP is equal to 0. Dot product is equal to 0. That. Number 3, replace the NP value and the ON value. What we get? I'll just rub this up. No need to call this as equation number 3. I'll just simplify. So next thing, replace the ON value. What is the ON value? From the equation number 1, D into N cap into dot product. NP value. What is the NP value? Dot product of R minus D into N cap is equal to 0. Is equal to 0. Just to simplify this one. How to simplify? Here, D is a scalar. One number is there. Simple into right hand side. What will get? N cap dot R minus D into N cap is equal to 0. Are you sure? D is simple into right hand side. Or dividing through by D. It is a scalar quantity. Dot product of two vector is again a scalar quantity. So that dividing through by D. N cap is left. Dot R minus D into N cap. Next, simplify. N cap dot R bar minus D into N cap dot N cap is equal to 0. So N cap dot R then minus D. Unit factor into unit factor. Dot product of two factors. A dot A is equal to what? Unit factor is the magnitude becomes a 1 is equal to 1, or else this value is 1 in this manner. Now this implies N cap on R bar into N cap is equal to D. R bar into N cap is equal to D because dot product of two vector is satisfy the commutative law. Dot product of two vector is satisfy the commutative law. So I just interchange, nothing to worry. R bar dot N cap is equal to D. This is the required vector form of the plane. This is the required vector form of the plane. Plane in the normal. This is the vector form of the plane. That is R bar dot N cap is equal to D. Where what is the D? D is the perpendicular distance from the origin. D is the perpendicular distance to the plane from the origin. Then what is the R bar? R bar is the position vector of the any point on the plane. Then what is the N cap? N cap is the unit vector in the direction of the normal. Unit vector of the direction of the normal. Terminology you should remember. So this is the vector form is over. Now we need to get the Cartesian form. How to get the Cartesian form? To get the Cartesian form, what we have to do? After getting the Cartesian form, take the components. What is the component? Let P having the coordinate. What are the point? P coordinate we need to choose. The coordinates of the point P, I just consider that x, y, z. Let x, y, z be the coordinates of the point. Coordinates of the point P. P of x, y with the coordinates, or else just coordinates. Just mention it. That's enough. Coordinates. Next thing, P is over. Then we will get the R value. From this, we can write the position vector R is equal. But we can write xi plus yj plus zk. Are you people sure? R bar and R bar is nothing but this one. OP value. What is this one? This we can write the OP vector. Next, so let L, M, N are the direction cosines of the unit vector N cap. L, M, N are the direction cosines. L, M, N are the direction cosines of the N cap because unit vector is the direction. So L, M, N are the direction cosines of the N cap. Then what we can get it? So unit vector can be written as N cap is equal to what is that? N bar divided by magnitude of the N bar. Are you quite sure? N cap is equal to unit vector of A. What is the unit vector? A bar divided by magnitude of the A bar. We know this formula in the vector algebra. Just replace it. What will get? And yeah, I just write this one. N bar divided by magnitude of the N bar. N. So this we can write unit factor is equal to Li plus Mj plus Nk. Now replacing unit factor and the factor are in the equation number. What is the continuous equation number? Equation number 3 is done. Replacing the equation number 3. Now the equation number 3 implies. What is the equation number 3? R bar is nothing but Xi plus Yj plus Zk dot product of Li plus Mj plus Nk is equal to how much? Is equal to distance we ask this. Now dot product of these two factors. What is the dot product of those two factors? That we can say Lx plus My plus Nz is equal to D. We plug with this one. A dot B dot A. Now the same. So to remember easily, I just written in this form. Lx plus My plus Nz is equal to D. This is the required partition form. This is the required partition form of the plane. This is the required partition form of the plane. Are you clear? Very simple derivation is that most of the time repeated in the examination. So here consider a plane. Then OA is perpendicular to the plane from the origin and its distance is given. What is the given thing? Equation of the plane in normal form. Normal form is nothing but, what is the normal form meaning? You should remember. Normal form is nothing but to the plane normal from the origin and its distance is given. Okay, so distance and the normal is given. In using that one, let out once again the same thing. Previously we just did the 2-3 derivation, and in the first PVC straight line also we just did that. Geometry consider on general point. This point is any point on the plane. In that manner you have to choose it. So position vector R dot product perpendicular of two vector is equal to 0. N will value just replace it, simplify, simply we just get the value. This is one. After getting the vector form, we can easily write the remaining thing. What is the remaining thing? Replacing the component form of the vector. If you replace the component form of the vector, replacing, simplifying, we will get the required Cartesian form of the required thing. Is that clear? Derivation is very simple. Starting point we have to get it. If you got the initial points, you can easily proceed the remaining full derivation. Okay, practice it 2-3 times. If you return means you will directly get the derivation. Nothing is complication is that. What is the node means? Previously we just taken here L, M, N are the direction cosines of the n term. Suppose if they given A, B, C are the direction ratios of the unit vector n term. If the A, B, C are the direction ratios, instead of giving the direction cosines, if they given a direction ratio. Already know the difference between the direction cosines and the direction ratios. Direction cosine means cosine value of angle of the line from the angle of the line, angle between the lines and the coordinate axis x, y and the z axis respectively. That is said to be the direction cosines. Alpha, beta, gamma are the angle between the line and the coordinate axis. Then cosine value of these angle is a direction cosines. Direction cosines. Word itself telling that direction cosine values of the angles. Direction ratios in them any number proportional to the direction cosines. Any number proportional to the direction cosines is said to be a direction ratios. Okay. Here A, B, C are the direction ratios of the unit vector. Then what we can write the unit vector? Unit vector can be written as AI plus BJ plus CK. Can we write that? Yes. Always we can write. Okay. Then what will be the equation of the plane? Then the equation of the plane can be written instead of the Lx plus My plus Nz is equal to D. Can we write that Ax plus By plus Cz is equal to D? This is also equation of the plane. This is also the equation of the plane. Are you well clear? Here Lx plus My plus Nz is equal to D. This is the Cartesian form of the plane. Here L, M and are the direction cosines of the normal to the plane from the origin. Here A, B, C are the direction ratios of the normal. The ratio of the normal from plane to the from the origin to the plane. Ripple clear. So if they given one general equation, for example, next particular example is that suppose if they given 2x plus 3y plus 6z is equal to 5 if they given. Here if they given, obviously we need to consider that 2, 3, 6 are the elemental. 2, 3, 6 are the directly how to consider as a n values. Are you clear? Suppose if we need to find the direction ratios, what we have to do? To find the direction ratios, any number is proportional. So that reason it is sufficient to divide by the L square plus M square plus N square under root. Are you clear? So we need to divide root of L square plus M square plus N square because any number is proportional. So that we need to divide to get the direction ratios from the direction cosines. Okay, one example I am just going to solve. You can easily understand the things. Okay, I have clear about this derivation. Very simple derivation is that practice it most of the time. You will predict the examination. Okay, now go to the examples. On the plane. Okay, so tell us over what we have studied in the plane. So first of all, the vector form of the equation of the plane is r bar dot n cap is equal to d. This is the normal form of the plane. Vector form of the equation of the plane in a vector form, equation of the plane in Partition form. How the plane is that? Plane is in the normal form. How? What is meant by plane in the normal form? That means plane, for that plane perpendicular from the origin and its distance is given. Here, what are the terminology? N cap is the unit vector, direction of the unit vector, origin to the plane, and r bar is the position vector of the any point on the plane, and where d is the distance of the plane from the origin. This is the vector form. And the Cartesian form. What is the Cartesian form? Lx plus my plus mz is equal to d. Where L, m, n are the direction cosines of the unit vector. Element of the direction cosines of the unit vector. Or else ax plus by plus cz is equal to d. Where a, b, c are the direction ratios of the unit vector. Terminology you should remember and the equation. How the shape of the plane. Okay, what is the given formula? Based on that formula, we are taking the example. Take it. Find the vector equation of the plane. Plane is that plane vector equation we need to find. Plane is that previously we have found out the equation of the line. In this video, we are going to find the equation of the plane. This plane is that. For example, this is the plane is that. This plane equation we need to find. How the plane is that? This plane is which is at a distance. This plane is at the distance of 6 by root 29. This plane is at the distance of 6 by root 29. From where? From the origin. This is a plane. This distance having the distance of 6 divided by root of 29. From where? From the origin. That means given thing. What is the given thing? This is nothing but a t divided by root of 29 is. Is that clear? Already in the formula, what is the d? D is the perpendicular distance from the origin to the plane. D is given and from the origin. Next, and it is a normal vector from the origin. Normal vector from the origin to the plane. Normal vector from origin to the plane is nothing but what? Normal vector from origin to the plane is nothing but, can I say that vector r? Vector r is equal to what? 2y minus 3z plus 4t. Is it a vector r or what? Once again, this is not a vector r. This is a vector n. Yes or no? Vector n or unit vector? Ripple clear? Normal vector. Normal vector from the origin to the plane. What is the r denotes? R denotes the, suppose the plane is this is the normal n from the origin and this is the point, this is the vector r, and this is the vector n. So distance is r, so that ON is equal to, is written that d into n cap. Make the difference. N cap is different. N cap is a unit vector. N is the vector. Are you clear? Are you clear? Here normal vector is given. Normal vector is given. There is nothing but n bar is equal to this one. But we don't need the normal vector. Actually, what we need, we just need the n cap. Suppose if the vector is given, some component form, how to find the unit vector of this one? I have already mentioned the formula in the derivation of the plane. What is the unit vector of A? That is vector A divided by magnitude of the vector A. Are you clear? So that from this n bar, we can easily get the unit vector n cap. What is the n cap? How to find the n cap? Is equal to 2i minus 3j plus 4k. Whole thing divided by magnitude is nothing but 4 plus 9 plus 16. Are you clear? 2 square plus 3 square plus 4 square is equal to 2i minus 3j plus 4k divided by 20 by 29 root of 29. This we can write as 2 divided by root 29i minus 3 divided by root 29j plus 4 divided by root 29k. This is the required unit vector in the direction of the normal to the plane. Normal to the plane of the origin. In this direction, the unit vector is going on. This is the unit vector. Distance is given, unit vector is given, then we can easily get the required equation of the plane. What is the required equation of the plane? R bar dot n cap is equal to d. So what is the R bar? R bar dot n cap. What is the n cap? Is here 2 divided by root of 29 minus 3 divided by root of 29j plus 4 divided by root of 29k. Is equal to how much? D. What is the D? Distance is given 6 divided by root of 29. Now simplify that one. Is it possible to simplify or is keep as it is? What is the final value? R dot 2 divided by root 29 minus 3 divided by root 29j plus 4 divided by root 29 k is equal to 6 divided by root of 29. This is the required equation of the plane. This is the required equation of the plane in vector form. This is the required equation of the plane in vector form. Find the vector equation of the plane. So this is the required equation of the plane in the vector. Very simple. If you know the standard derivation group and terminology involved in that, you can easily solve any problem regarding that one. Okay, I hope you will understood this one. Simple problem. Now, based on that formula only, let's take different kind of the problems. For take problem, find the direction cosines of the unit vector perpendicular to the plane r bar dot 6i minus 3j minus 4k plus 1 is equal to 0, passing through the origin. Okay. So we need to find the direction cosines. Clearly understand the question. We need to find the direction cosines. Direction cosines of what? Direction cosines of what? Direction cosines of a plane, or direction cosines of a line, or what? Or direction cosines of the unit vector. Unit vector is the unit vector that I just represents the n cap. Direction cosines of the unit vector. How this unit vector is a unit vector of what? Whether unit vector of A or unit vector of B, particularly need the value. So unit vector of what? Unit vector from where? Unit vector perpendicular to the plane. That unit vector is perpendicular to the plane. Unit vector is perpendicular to the plane. This is the plane. This is the unit vector perpendicular to the plane. From where? Perpendicular to the plane. This is what? This is the equation of the plane. Literally, r dot n cap is equal to obviously not in the standard form. What is the standard form? R bar dot n cap is equal to d. This is the vector form is given because r bar is there. So this is the plane equation given. So they only mention that to the plane. Particularly mention that plane. This is the plane equation passing through the origin. Passing through the origin what? Whether the plane is passing through the origin or required unit vector is passing through the origin. Unit vector is passing through the origin. I hope you people have got the meaning of the question. We need to find the direction cosine of the unit vector from which unit vector? This unit vector is perpendicular to the plane from the origin. Plane equation is given from the passes through the origin. That unit vector is passes through the origin. That means obviously this is the standard form. So now we need to find the unit vector. First of all, we need to find the unit vector. After getting the unit vector, we can easily get the direction cosines. Okay. So direction cosines, how to find that? First of all, write the given thing. What is the given thing? Equation of the plane is given. R dot minus 6i minus 3j minus 2k. 1 I just shift into right hand side. If I shift the 1 into right hand side, what will get? Minus 1. But right hand side is the distance always measured in the positive quantities, which is never becomes a negative. So multiplying throughout the equation. R bar dot minus 6i plus 3j plus 2k is equal to 1. Are you clear? Now this becomes a factor n. This is not a n, this becomes a factor n. That is minus 6i plus 3j plus 2k. Here it is a factor n which is called. But actually we need the n cap. To get the n cap, what we have to do? So magnitude of the n bar is required. What is that? Root of 36 plus 9 plus 4. What is the value? 36, 45, 49. Root of 49 is equal to consider the only the first value. So for this equation number 1, dividing throughout by 7. Divide by 7. Divide by 7 to the equation number 1. What we get? R bar dot minus 6 by 7i plus 3 by 7j plus 2 by 7k is equal to 1 by 7. Now this is the equation of the plane in the normal form. This is the equation of the plane in the normal form. This is the equation of the plane in the normal form. So that n cap value, what is the n cap value? It becomes minus 6 by 7i plus 3 by 7j plus 2 by 7k. What is this one? This is the n cap, that is nothing but this is the unit vector. This is the unit vector of the plane. Unit vector of the plane from the where? From the origin. This is the unit vector of the plane from the origin. Now what we need to find? Direction cosines of the unit vector. Just now only we found out the unit vector to the plane from the origin. Now we need to find the direction cosines. Therefore, here we have decided. Therefore, direction cosines of the unit vector is, what are the direction cosines? Minus 6 by 7 plus 3 by 7 and 2 by 7. This is the required direction cosines of the unit vector. That unit vector is perpendicular to this plane and passing through the origin. Is that clear? Clearly understand the question. Okay. Find the coordinates of the point of the perpendicular drawn from the origin to the plane. This is the plane 2x minus 3y plus 4z minus 6 is equal to 0. Okay. What we need to find? Suppose the plane is that. This is the plane is that. This plane equation is given. What is the plane equation? 2x minus 3y plus 4z minus 6 is equal to 0. Equation of the plane. They only mean equation of the plane. In which form? Whether it is a vector form or Cartesian form. It is in the Cartesian form. Is that clear? This is the Cartesian form is that. So Cartesian form of the line, we know that. What is the Cartesian? It's not a line. Cartesian form of the plane. Lx plus my plus nz is equal to dy, or ax plus by plus cz is equal to d. First case, where L and N are the direction cosines, A, B, C are the direction ratios. This is the Cartesian form. These are in vector form. What is the vector form? R dot n cap is equal to d. R dot n cap is equal to d. Where n cap is the unit vector perpendicular from the origin to the plane. R bar is the it is the position vector of any point on the plane. Okay. Now here this is the plane is the x, y, and the z. Graph diagram I am just trying to draw. This plane is this in this manner. This is the plane from the origin, x axis, y axis, and the z axis. We need to find that coordinates of the foot of the perpendicular. Coordinates of the foot of the perpendicular. Suppose one point P is there. This coordinate we need to find foot of the perpendicular. Foot of the perpendicular. Perpendicular is drawn from where? Drawn from the origin. Perpendicular is drawn from the origin. This is perpendicular to here. We can extend it. Are you clear? So the foot of this coordinates, the P coordinate we are required to find the foot of the perpendicular. Find the coordinates of the foot of the perpendicular. Perpendicular is drawn from the origin to the plane. This is the plane equation is given. So given plane equation is 2x minus 3y plus 4z is equal to 6 as is right, because minus 6 is shifted into right hand side. Are you clear? So here we need to find the coordinates of the point P. In first we see straight line, also just found out the foot of the perpendicular. How? Suppose one triangle is that, then drawn a altitude. It is passes through the point A, then find the coordinates of the foot of the perpendicular. Have you remember? Is that clear? So in this manner, here coordinates of the foot of the perpendicular drawn from the origin to the plane. How to find? Here, first of all, I just rewrite the equation of the plane. How to rewrite the equation of the plane is nothing, but I just write in the unit vector manner. What happens if I write the unit vector manner means? So write unit vector manner, or else I need to get the direction cosines. L, M, N. Lx plus my plus mz is equal to d. So this is not a unit factor. So that what I just will do, dividing by root of 2 square plus 3 square plus 4 square. That is nothing but root of 29. Dividing with root by root 29. What will we get? 2 by root 29x minus 3 by root 29y plus 4 by root 29z is equal to 6 by root 29. Now this is the equation of the plane in the Cartesian. Equation of the plane in the Cartesian form. So here the direction cosines value is called. What are the direction cosines? Direction cosines are 2 by root 29 minus 3 by root 29 and 4 by root 29. Now the direction cosines of this plane, or direction cosines of the unit vector is what? 2 by root 29 minus 3 by root 29, 4 by root 29. Yes, in your mind one doubt is that. What is the doubt? Sir, consider 2x minus 3y plus 4z is equal to 6. Now it is of the form Lx plus My plus Nz is equal to D. So D is equal to 6 unit. Then L is 2, M is minus 3, N is plus 4 are the direction cosines, which is not possible. Why it is not possible means these are L and N are the direction cosines. Now here it is a unit vector is there. If you take on this one, this becomes this is not a stable one. This is a unit vector is there. We have to find the unit vector. To get the unit vector, we use the vector A divided by magnitude of the vector. That is always in the vector form there. So we need to get the unit vector component, scalar component of the unit vector. To get the scalar component of the unit vector, compulsory we need to divide that. This is squares. This a square or x1 square. L square plus m square plus n square under the root. Are you well clear? Remember this one. Okay. These are the direction cosines. Next, first of all, we need to find. So next one, let P be the point having the coordinate x1, y1, z1. P P with the point. This is the P having the coordinate x1, y1, z1 with the foot of the perpendicular. With the foot of the perpendicular. That is the foot of the perpendicular on the origin. Foot of the perpendicular on the origin. In this case, x1, y1, z1 are the coordinates of the point P. Then this is the foot of the perpendicular. Then can I say that these are the direction cosines of the normal to the plane, because it is becomes a normal in this direction. This is becomes a n cap. What is the n cap value? It becomes n cap value. Can I write that x1i plus y1j plus z1k. Now these are the direction ratios. Here I just change a small thing. Here these are the direction ratios. x1, y1, z1 becomes a direction ratios of the unit vectors. So here this is the P of x1, y1, z1 with the coordinates of the foot of the perpendicular from the origin to the plane. Origin to the plane. That x1, y1, z1 are the direction ratios of the line. And hence one more thing we know that. I just write that. Okay. And but we know that it is the known result means direction cosines and direction ratios are proportional. Direction ratios and direction cosines are proportional. So direction cosines and direction ratios are proportional means I have just taken the x1, y1, z1 are the direction ratios and these values are the direction cosines. So when I write this value as x1 divided by 2 by root 29, x1 divided by 2 by root 29 is equal to the y1 divided by minus 3 by root 29 is equal to z1 divided by 4 divided by root 29. This is value is equal to k. Why just consider in that manner means because direction ratios and direction cosines are proportional to each other. Proportional means I just taken a proportional is equal to some constant k. Now simplifying this will get what will be the x1 is equal to x1 is equal to 2k divided by root 29. I will play next. y1 is equal to minus 3k divided by root 29. Then similarly z1 is equal to 4k divided by root 29. 4k divided by root 29. Are you clear? Sorry, this much is equal to this much is equal to this much is equal to this. Next here, x1, y1, z1 values are in this manner. Here only we just consider foot of the perpendicular of x1, y1, z1. I only consider. Here unknown value k is there. We need to find the k value. How to find the k? As we know that this is x1, y1, z1 coordinates of the point P. Where the point P is there? Point P is present on the plane. Whether the point P is present on the plane? Yes. Point P is present on the plane is nothing but the coordinates of the point P must be satisfy the equation of the plane. Coordinates of the point P must be satisfy the equation of the plane. Do you agree? Suppose when point P is there on the plane, that means the coordinates of the point P must be satisfy the equation of the plane. The coordinates of the point P, x1, y1, z1 is the coordinate of the point P is satisfying the equation of the plane. Is satisfying the equation of the plane. The equation of the plane, I just consider equation of the plane. This is the given equation of the plane. Replace the x1, y1, z1 into the equation number 1. What we get? Equation number 1 equals 2 into x is nothing but x1 value. What is that? 2k divided by root 29 minus 3 into y1 value because it is point. This is the point of the plane. Divided by root 29 plus 4 into z1 4k divided by root 29. This is the root 29 is equal to how much? Is equal to 6. solve it. This is 2 to 4k divided by root 29 minus plus 9k divided by root 29 plus 16k divided by root 29 is equal to 6. Is equal to 6 is that. Now simplify. What will get? Root 29, root 29, root 29 is LCM and simplify to right hand side. 4k plus 9k plus 16k. 13 and 29. 29 times of k, 6 into root 29. So k is equal to 6 into root 29 divided by 29. That implies k is equal to 6 divided by root of 29. K value is called as 6 divided by root of 29. But actually, what we have to get? We need to get the coordinates of the foot of the perpendicular. What is the coordinate of the foot of the perpendicular? X1, Y1, Z1 is the coordinates of the foot of the perpendicular. Therefore, where is the X1? X1 is here. Replace the K value. What is the X1? 2 into K value is 6 by root 29. So X1, wherever K is there, replace the root 29. 2 divided by root 29. 2 divided by root 29 and k value is 6 divided by root 29. Simplify. So 2 into 6 divided by root 29. Root 29 is 29. So this we can write as a 12 divided by 29. Are you all clear? Similarly, get the y1 is equal to. What is the y1 is equal to? Minus k value is 6. Minus 3 into 6. 18 divided by 29. Z1 is equal to. What is the Z1 is equal to? Z1 is 4 into this one. 24 divided by 29. Therefore, finally, the x1, y1, z1 is equal to how much? X1, y1 is z1 is the foot of the perpendicular. That is 12 divided by 29 minus 18 divided by 29 and 24 divided by 29. This is the required coordinates of the foot of the perpendicular drawn from the origin to the plane. So this is how we need to find. Plane equation is given. We need to find the coordinates of the point. So this is manner we have to solve the problem. Hence the solution. Very important type of the question for 3 marks. Okay. Now I just stop here. Practice the standard derivation in the normal form of the plane, and we'll continue in the next video. Okay, thank you.